Welcome students, myself Mr. P.P.Sutar, Associate Professor, Department of Chemistry, Gopal Krishna Gokhale College, Kolhapur. Students, in the previous lectures, we have seen the knowledge about UV visible spectroscopy. Today, we are proceeding further. Now, today we are going to learn what are the modes or types of electronic transitions. Now, students, as this UV visual spectroscopy is also known as electronic spectroscopy, there are the transitions of electrons from lower energy level to higher energy level. Now, students, see what types of electrons are there. The electrons that is forming sigma bond, that is called as a sigma electrons. The electrons in the pi bond, that is the pi electrons, and the electrons present as a non-bonded, that is a lone pairs, they are called as a non-bonded electrons, and therefore the transitions may occur from these various energy levels, that is from sigma, pi and n. Okay, let us see one by one. It is a sigma to sigma star, that is sigma bonding to sigma anti-bonding transition. Of course, it is the promotion of electron from the sigma bonding to sigma anti-bonding orbital. Now, students, in this diagram, the various energy levels are shown. This is the first one is a sigma, then pi orbital level, then non-bonded electrons present in this orbital. Then these are the anti-bonding levels, that is a pi anti-bonding, and the last is sigma anti-bonding. Now let us see various types of transitions. The transition, let us see, the first transition I am showing is sigma to sigma star. The next one is sigma to pi anti-bonding, that is a pi star. The next one is pi bonding to sigma anti-bonding, that is sigma star. The transition from non-bonded orbit, that is n to sigma star, again from pi to pi star, and the final n to pi star. Now these various transitions occur. Now when we observe the diagram, the transition of electron from sigma to sigma star requires more energy. Look, this is the more energy gap between these two energy levels, and therefore more energy is required for this transition, and therefore the wavelength having more energy, that is the shorter wavelengths, are required for such a transition, while the transition from non-bonded n to pi anti-bonding, that is n to pi star, is of lowest energy, that is a longer wavelengths are required, and therefore see the what is the order of the transitions requiring the energy, that is these energy transitions are, the first lowest energy transition is n to pi star, then energy increasing for pi to pi star, then higher energy also required for n to sigma star. The next transition occur at higher energy is pi to sigma star. Next one is sigma to sigma pi star, and the final is highest energy required for sigma bonding to sigma anti-bonding transition. Thus these are various types of electronic transitions. Let us proceed further. Now, let us see the effect of conjugation on the position of UV visible band. Now, in the UV visible band, what is the effect when conjugation is increased? What is the effect on the band? Now, the conjugation, that is pi bonds in alternate order, that is pi bond, sigma bond, pi bond. Yes. Now, alkenes containing one double bond or multiple double bonds, but that is isolated double bonds, that is separated more than one single bond, are known as isolated. That is, double bond is present but it is not in conjugation, and such double bond is isolated, and therefore such alkenes are called as isolated alkenes. There is a transition from pi to pi star, but this transition occurs in 165 to 200 nanometers. That is a transition which is lower wavelength. Okay. Now, when the double bonds are in conjugation, the absorption shifts to the longer wavelength. When there is a conjugation, the first one was isolated double bonds. When conjugation, that is these bonds are separated by only one single bond, that is a conjugation, and therefore shift of the wavelength towards the longer side, and therefore longer the conjugation, longer the lambda max and E max value. Isomeric conjugation diene 1. If there is a triene and there is a tetraene, yes, we will observe. And what is the effect? There is with increasing conjugation from 1 to 2 to 3, the lambda max value also goes increasing. Let us have the figure. Yes, in the first, this is the first one. Here only two bonds, double bonds are in conjugation. The third one is in the isolated condition, and therefore the effect of only these two pi bond, they are in conjugation, double bond, single bond, double bond. Here the conjugation is not increased, and therefore the wavelength is on the shorter, that is the less side. That is when in the second case the conjugation is increased, that is a double bond should be separated by only one single bond. This is the conjugation increased, the wavelength is shifted towards the longer side, and also this Emax value is also increased. Look on the first diagram, the Emax value is low. In the second case, this is the increased. Okay. In the third case, triene, and this is a tetraene. 1, 2, 3, 4, tetra, 4 double bonds. Of course, conjugation is increased, and therefore there is a shifting of wavelength towards the longer side, and this is the band, UV visible band, that is of tetraene, and therefore also there is a increase in the Emax value. Okay, and thus what is the effect? When the conjugation increases, the absorption shifts to the longer side, and also the Emax value also increases. Okay, and these are the examples, gives the clear idea about the effect of conjugation on the band. Okay, now as we have seen, there is an effect of conjugation on the absorption. The radiation of longer wavelengths are absorbed with greater intensity. What are the types of shifts with increasing conjugation? Look here. The first, when there is an alkane compound, of course there is a no pi bond. The transition occur of a sigma bonding to sigma antibonding. The absorption band is lambda max at 135. If there is only one bond, pi bond, that is double bond, then there is a transition of pi bonding to pi antibonding electrons, but the absorption is again at 175 lambda max value. If it is increased, okay, say third example, the double bonds are present but they are not in conjugation, they are in the isolated state. Okay, the double bonds are separated by more than one sigma bond, and therefore this is isolation. There is no change in the value. Again it is a 175, like that previous. When the double bonds are in the conjugation, look here, double bond, single bond, double bond. Again there is of course pi to pi star transition. The lambda max values somewhat increased to 217. If there is a increased conjugation in the next case, double bond, single bond, double bond, single bond, double bond, that is increasing conjugation present, which affects on the wavelength absorption, and the absorption towards the longer side, it is at 258 nanometers. Thus, when conjugation increases, the absorption band shifts to the longer wavelength. In case of beta carotene, it is the 415 nanometer, the value of lambda max, which we are going to see in the next. Okay, this is the beta carotene. Okay, look here, double bond, single bond, 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 double bond. Look how much conjugation is increased, and this increased conjugation absorbs the wavelength of longer side. The absorption, that is the lambda max of this compound, is at 415 nanometers. The second example is also like pin, which is also containing more conjugated double bonds, and therefore again the lambda max value is shifted towards the longer wavelength, that is the 474. Okay, and this is the clear cut knowledge that is having. When the conjugation increases, there is a shift of wavelength towards the longer side. Okay, now again the chromophores containing heteroatom like oxygen, sulfur, nitrogen also absorb the longer wavelengths. Coupling of such groups with our olefinic compound in conjugation deepens the red shift, that is to the shifts towards the bathochromic, that is towards the red, and thus when these groups are present with our olefinic group, okay, when there is a values are given, that is UV-visual bond, what is the N value increases when N equal to 1, that is there is only one pi bond, what is the value, 217, where there are two double bonds in conjugation, then the value is increased to 270. Also the Amax value is going on increasing when there is a increase in the value of N. This is the value of N. Okay, as N increases, lambda max increases, also the intensity increases. Now, according to molecular orbital theory, pi electrons are further delocalized by conjugation. As a result, the transition energy of pi to pi star transition is lowered. Energy is lowered, the absorption shifts to the longer wavelength. Students, what you all learn? Yes, the introduction of double bond in conjugation with chromophore causes red shift, that is a bathochromic shift, with a corresponding hyperchromic effect. Okay, and that is the UV visible band is shifted towards the longer side, and this effect is also observed in both pi to pi star transition in alkenes and also N to pi star transitions in carbonyl compound, that is when these compounds are present in the molecule, the effect of shifting of wavelength towards the longer side takes place. Thus, with this I conclude my today's lecture. The remaining point from the topic will be discussed in the next lecture. Thank you.